Zach Althouse, and I am in the robotics automation program.
Okay, what you got here?
This is basically an automated recycling facility. The idea behind this was I wanted to be able to tell the difference between an aluminum can, clear plastic, and an opaque material.
Okay.
To do that, I use different kinds of sensors that you see here. These two black ones are capacitive sensors. That's going to detect most things in front of any liquids, metals, anything like that, even your hand. As you can see, this light back here kind of turns on. You put your hand right in front of it. That's going to know something's right there.
Yeah.
So everything here is controlled by the PLC, that's programmable logic controller. Basically, it just accepts electronic signals as an input and then also outputs electronic signals. It's kind of the home base of everything here. Everything talks to this, and then this talks to everything out here. On the right-hand side of the screen here, that's what's used to program the PLC. This is ladder logic style program using the Rockwell software. If you see this right here called Master Start, that's referring to this button here.
Yeah.
Named Master Start, that's just something I named so I knew what it was. This tag right here is actually the physical address where it's located. The local 3i data.11 refers to this input card here. All that means is that this switch is wired to pin 11 on this card. You know exactly what it's wired to.
Right.
The hydraulic system functions in the same way. There's a switch in here that will close once there's pressure applied to it, and it'll just send an output signal to the PLC, and it'll switch this hydraulics light on. Basically, it's a safety feature. Nothing's going to work until everything is on. Now, the robot light here is on already because I have the robot script running. That's on the left-hand side of the screen. Basically, all this is, if you look here, it says, let me go to the top, go to position 1. All that means is I've made it go to a position. I call it position 1. It's saying go here. Basically just pick and place, open gripper, close gripper kind of thing. It has some inputs and outputs, which is why this light is on. When the script is running, it's going to turn an output on robot controller, activate an input on the PLC, and it'll turn the light on.
Okay, good.
When I switch on the hydraulic pressure, you see how the
this is just a hydraulic pump that's kind of pressurizes everything.
Yep.
For you. Okay, cool.
Once everything is ready, everything's up and running, the ready light's going to turn on, and everything's ready to go. Let me just download the program. And all this is doing is putting what I have here onto the PLC.
Yeah, I bought it direct from China. I'm cheap that way.
So once everything is powered up and ready, I wanted this to be designed so that if there was nothing on the conveyor belt, you hit start. Nothing's going to happen. Like I said earlier, you can see this light turns on when you put something in front of it. Right. Once something is there is when it's going to start. And if I press start, it's going to move down the line. This sensor here sends a light pulse out, and there's a little reflective disc here. The light pulse is going to be reflected back into it. Since this is clear plastic, it's not going to trip that sensor, so it knows that it's clear. And all it's going to do is send an output back to the PLC. See how output number 2 is turned on there? All that is referring to is that the clear plastic bottle was approaching here, and it's just going to pick up and place it. Now, similarly, if I did it with this one, it's going to trip this signal since it's completely opaque. And all it's going to do is know that it's the opaque bottle and place it in here. Now with the can, once this moves down the line here and hits this is an inductive sensor, and it's only going to detect the metal. It's going to stop here, know it's the can, and it's going to move it over to the can crusher over here.
That's what we want to see.
Yeah, that's the exciting part.
Yeah.
Are you familiar with any coding languages at all?
Women and children stand back, right?
Now this was the most difficult part by far. It's kind of really, there's not very much space between the can and the inside the crusher itself, so it was a lot of very precise movements. And as you can see here, that didn't exactly work how I wanted to, because every time the can gets picked up, it's not going to get crushed in the exact same way.
Right.
You know, it'd be better if I had some sort of camera that'd be able to tell exactly where I'd be able to pick it up, but. I'm just going to drop it here.
pretty cool. Yeah. Great.
A lot of stuff here was modified from parts I had available to me. For instance, this conveyor belt is actually meant to interface with the robot controller. If you see back here, there's a serial port that has some lead solder to it.
Yeah.
That's just supposed to be connected to here. What I wanted to do is have that controlled directly by the PLC instead of having to go through the robot controller, then to the PLC. Save some wiring, saves me a lot of time and hassle.
Yeah.
So all I did was solder 2 leads onto the pins that control the motor on the conveyor belt. Just hook up to the PLC, so if I send an output signal to that, it's going to turn the conveyor belt on.
All right.
You can see a lot of stuff here has been bolted down so it doesn't move. That's for the sake of the robot. The robot doesn't know where it's at in space. It has set movements based on where the base is. So if this gets bumped at all, every position that I had made is going to be lost, and I have to do it all over again, which caused me a lot of hassle when I was working on this. So as you can see here, I kind of bolted it down to a big piece of cork board here, and then stick it to the table so it wouldn't move.
Yeah. All right. Nice job. Thank you. Yeah. All right.